Recall that the unit circle is one of the ways that we can compute the values of trigonometric functions. If we draw the unit circle and draw an angle in standard position, the coordinates of the point where the terminal side intersects the unit circle gives us the values of the functions according to this chart. On the unit circle, there are some important coordinates at certain angles that you must know. In a later video, we will derive the values of this using the Pythagorean theorem, but for now we will simply learn them heuristically. We begin with the angles built around increments of pi over 2, or 90 degrees. As we work our way around the circle, we get the angles of 0, pi over 2, pi, 3 pi over 2, and 2 pi, which is coterminal with 0. The coordinates of these angles are easy to remember because they all lie on the coordinate axes. All you need to remember is that the unit circle has radius 1, and this will tell you exactly what the coordinates are for each of these angles. We will next look at the angles built around increments of pi over 4, or 45 degrees. In addition to the previous 4 angles, we also get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All of the new coordinates will be a plus or minus square root of 2 over 2. The signs of these coordinates will correspond to the quadrant. In the first quadrant, both coordinates are positive. In the second quadrant, the x-coordinate is negative and the y-coordinate is positive. In the third quadrant, both coordinates are negative. And in the fourth quadrant, the x-coordinate is positive and the y-coordinate is negative. Lastly, we will look at the angles built around increments of pi over 6, or 30 degrees. In addition to the angles we already have, we will also get pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and 11 pi over 6. Each of these new coordinates will either be a plus or minus 1/2 or a plus or minus square root of 3 over 2. You will be able to identify the proper signs by looking at the quadrant, but you also need to use some logic to figure out which is which. The important fact to remember is that the square root of 3 over 2 is greater than 1/2, so that when you look at the picture, you will be able to just choose the coordinates that correspond to this fact. For example, at pi over 6, the x-coordinate is greater than the y-coordinate, so the x-coordinate gets square root of 3 over 2, and the y-coordinate gets 1/2. At pi over 3, the y-coordinate is now larger, so that one is square root of 3 over 2, which makes the x-coordinate 1/2. This pattern continues all the way around the circle. This looks like a lot of information, and it is. But by thinking this through and paying attention to the signs and with a little bit of practice, you can work your way around the entire unit circle and get all of these values. The points in the first quadrant are very important in this course. Recall that the coordinates are related to the sine and cosine functions. You are expected to memorize these and be able to reproduce them on command. Fortunately, it takes just a little bit of practice to get these values to stick. Notice how sine starts at 0 and the numerators count up. Cosine uses the same values, but in the opposite order. This will help you keep all the numbers straight. You can also look up the sine and cosine finger trick if you're still having problems. As a side note, square root of 2 over 2 is approximately 0.707, and square root of 3 over 2 is approximately 0.866. These are useful values to know, but it's more important that you know the exact values and not the numerical approximations. In the next video, we will look more closely at these values and make a further observation about our trigonometric functions based on the unit circle.